Good afternoon, class. Today we're going to continue Chapter 8 with 8.2. 8.2 is going to have some graphing in it, so if you don't have a graphing calculator, make sure that you either have your cell phone with your graphing app, or if you can, pull up another section with either that desmos.com or another graphing calculator website. That way you can actually see what these look like as we're going through them. Now, first thing, rational functions. We talked about rational functions first semester, but it's been a long time. But a rational function is where we have two polynomials. So we have a polynomial p of x and q of x. And if you don't remember, polynomials are monomials, binomials, or trinomials. Mono meaning one term, bi meaning two terms, tri meaning three terms. So we have polynomials, and it can be in any shape, any size, and it makes a rational function when they're division. You have one on top and one on bottom. So an example of a rational function would be 4x minus 2 divided by x minus 1. That would be a binomial divided by a binomial. But like I said, you don't have to have bis. You could have monomials, you could have trinomials. It can look a lot of different ways. Now, q of x can't equal 0. Hopefully we recognize by now we can't have a 0 on the bottom. So q of x will never be 0. Now, parent functions. We've looked at almost all of these. Two of the ones that we have not looked at are these bottom two down here. Okay, and the one that we're going to look at today is right here. This is our reciprocal function. Reciprocal function is 1 over x. Okay, so we're going to have two different sections to this graph that we're going to talk about here in a second. But this is our parent function that we're going to be looking at today. Now, parent function of a simple rational function. Okay, rational again meaning that we have some kind of division. So our parent function for a rational function is right here. Y equals 1 divided by x. Okay, and if you haven't graphed that yet, go ahead and plug that in. Y equals 1 divided by x. Hopefully you'll get something like what you see down here on the bottom. Okay, this is our parent function for these rational functions. Now, when you look at this in your calculator, this hopefully is exactly what you see. You have two different sections of the graph. This graph, this type of graph is called a hyperbola, where you've got these two different sections like this. And it consists of two symmetrical branches. Okay, keyword here is it says symmetrical. These are going to be symmetrical. Hopefully we recognize symmetrical means same shape, same size. Okay, and when we look at our calculator, hopefully we can identify that. Those branches will be symmetrical. Domain and range, we're going to keep continuing on with domain and range. For this specific graph, it's going to change when we shift, but for this specific graph, my domain and range is all non-zero real numbers. That tells me two things. Non-zero tells me everything but 0, so it cannot be 0. Real, remember real only means one thing. You cannot have what? Real means you cannot have imaginary, so you can't have i's, but everything else works. Radicals, decimals, fractions, everything works except for imaginary. Vertical asymptotes will always be x's. Okay, and why? I put it on the picture here at 0. I have a vertical asymptote at 0. But why is it always going to be an x? Because of our saying. We have a saying, our hoi lux. And if it's a vertical asymptote, it has to be an x equals. Horizontal asymptotes for this question is at y equals 0. But horizontal is always going to be a y. Again, why? Our saying, hoi lux. If it's a horizontal, it has to be a y. Okay, and again, for this question, the asymptote is at 0. Now, what do you recognize about those asymptotes and where they're at on our graph? Well, we have our two symmetrical branches over here, and our asymptotes are going to be going through what I'm going to call the middle. Okay, and remember, why? The definition of that asymptote is where it gets closer and closer and closer, but it never touches. So it has to go through the middle of these two branches. So both of them go off to infinity in either direction, but they're never going to touch that asymptote. And it goes both directions, horizontal and vertical. Now, you're going to look at two different kinds of parabolas. This first kind over here in yellow and the second kind over here in orange. They're very similar, but they're going to have a little, the rules are going to be a little bit different. The first one, the asymptotes for the first one are pretty easy. The asymptotes are going to be at h and k. So your asymptotes for this first one is going to be x equals h and y equals k. Now, notice this is x minus h and this says x equals h. So again, what do we have to recognize? That h is going to be reversed because of this minus sign, just like we've done in the past. Y equals k, this is a plus k, so whatever k is goes right here. That one doesn't change, but this minus h, remember that one's going to change because that one's a negative up there. Now, domain is going to be restricted by what kind of an asymptote? Domain is going left to right, so your domain is going to be restricted if we have a vertical line that's going to be stopping it. Okay, so domain is going to be restricted by a vertical line. Well, which one of these was vertical, the x or the y? If you don't remember, again, think of our saying, hoi bucks. Which one's restricted by vertical? Vertical is my x. So my domain is going to be restricted by that h. So it's going to be everything from negative to positive infinity except for where that asymptote's at. Because remember, asymptote, we can never touch it. So it's going to be everything except for h, and that's what this h with that union in here is talking about. Range is my up and down. So how can up and down be restricted? With what kind of a line? A horizontal line. So if I'm restricting my range, it's going to be with a horizontal line that's cutting inside here. So if it's horizontal, it's going to be what? It's going to be the y. So this k is what's restricting the range. It's going to be everything except for that y, or that k. Now, the difference between these two, there's just one small difference, and it's the polynomial up on the top. On this first one, it's just a, so a is just a constant. But up on this second one, it's an ax plus b. So when you have the second type of hyperbola, you're going to have an actual polynomial up here on the top, an ax plus b polynomial. That's how you know which one you're looking at. If you just have a number, you're over here in the yellow. And if you actually have an x, if you have a polynomial, you're over here in orange. Now, the asymptotes are going to be similar. The first asymptote over here was x equals h, okay? And that would be the same thing as if you put it equal to 0. You would have to add h to both sides, so you would get x equals h. You're going to do the same thing over here. Your x asymptote is going to be where you put the bottom equal to 0. Okay, so I'm going to still call that h, but that's where the denominator equals 0. Okay, so that's the same thing on both sides. X equals h, and that's always where the denominator equals 0. The y asymptote's what's different on this one. It's a over c. Come up here and look to where we're getting this a and this c. A over c are the two numbers that are in front of your x's. So when we're looking for this y asymptote, it's those two numbers that are in front of your x's. That's what's going to give us our y asymptote. Okay, and again, the x asymptote is always going to be our vertical up and down going through our hyperbolas, and our y asymptote is always going to be our horizontal going through our hyperbolas. Okay, domain is the same thing. What do we say over here? Domain is my x's, so it's going to be restricted by that vertical x. Okay, so in this case, that vertical x again is h, so it's negative infinity to positive infinity, but we can't touch h. So that's what we're showing inside here. And our range, again, range is up and down. That's our y's. It's restricted by that horizontal y. And that horizontal y in this case is our a over c. So whatever that a over c is what's restricting our range. Now let's look at a couple examples. When we do these examples, you're going to graph it, obviously. Domain and range like we've been doing. And I also want you to tell me those horizontal and vertical asymptotes. So my first example, 3 divided by x minus 1 plus 2. Step 1, before you even type it in your calculator or do anything else, I want you to tell me what these asymptotes are. You don't need a calculator for that. This is the yellow type. This was that first type. All I have is a 3 up here. Okay, so if you're looking at your notes, this is type 1. This is that yellow type. What did we say? My x asymptote is always where you put the bottom equal to 0. So my x asymptote would be x minus 1 equals 0. So what's my x asymptote? X equals 1. My y asymptote for this type of hyperbola, where did it come from? Comes from the outside. So my y asymptote would be y equals 2. Now, when you graph this in your calculator, do you actually see the asymptotes? Yes, but no. You kind of see where they should be, okay? But make sure you're finding them by hand so when you look at your calculator, you can tell yourself or ask yourself, are these correct? Okay? When you graph it in your calculator, all you see are the branches. Okay, so step 1 is asymptotes, and this is hoi vux. So I have a horizontal line at 2 and a vertical line at 1. So draw those two on there. I have a horizontal line at 2. Remember they're dotted because they're not really there. And a vertical line at 1. Okay, so I have my two asymptotes. Now going back to what we set up here, what do you see in the calculator? All you really see are the branches. And the calculator is only going to tell you which set of branches you're drawing. You're either going to have a branch up at the top left and the bottom right, or the top right and the bottom left. And that's all your calculator is telling you, is where they belong. Okay, so you see your branches in your calculator, you have your asymptotes on your graph, so now all you're doing is filling it in. So there's my branches. They belong in the top right and bottom left. Now our domain. Remember our domain is our x's. Okay, so it's going to be everything except for where this asymptote is at. So x's. So when I look at this picture, I have a branch going off to the left, and it's never going to stop. So that branch is going to the left. So that branch is going to negative infinity. Then where does that branch stop? It goes to negative infinity. It comes through here. And this branch stops where? Goes down and it stops at 1. It stops at that asymptote. Then I can join that, have a union with this one up here. Where does this branch start? This branch starts at the asymptote. It starts at 1. And then it continues in what direction? It continues going to the right. So it continues going all the way to positive infinity. So my domain is everything, negative to positive, except for that asymptote, except for 1. Neither one of those branches will touch that 1. Okay, so let's look at our range. This down here is going to keep going down. It's going to keep going down to negative infinity. And remember, that's because our range is our y's. So negative infinity, and then we come up, and where does this branch right here stop? It stops at the asymptote. So where will it keep getting closer to but never touch? Where are we at right here? 2. And then what are we going to join that with? This asymptote up here this branch up here starts at the asymptote. So that one starts at 2. It's never going to go below it. It starts at 2, and then it's going to keep going up. So it's going to keep going to positive infinity. Okay, so similar concept to what we've talked about in the past, but now we're putting a little mix into it with having 2 asymptotes now. So let's look at one more. Now, this is our type 2. This is our orange one. And why? Because I have a polynomial, a binomial up here on the top with an x. Okay, so when I'm looking at my asymptotes, it's a little bit different. Now, remember your x asymptote is still the same. It's where the bottom equals 0. So my x asymptote is where 3x plus 3 equals 0. We'll solve that out. We get 3x equals negative 3. Therefore, what's my x asymptote? X equals negative 1. My y asymptote. Remember the y asymptote when we had the polynomial of the polynomial was a over c. And what did we say? The a over c were the numbers in front of the x's. Well, there's nothing up here in the top in front of the x. So what is it? That's a 1. So my a over c is going to be y equals 1 over 3. So again, before you even type it in your calculator, you know these two things. So draw your asymptotes. So hoi, 1/3 is my horizontal line, thus -1 is my vertical line. So I have my two lines, vertical at -1, horizontal at 1/3. Now we're going to use our calculator, so type it in your calculator so we can fill in our branches. And again, we're either going to be up here on the top left and the bottom right, or top right and bottom left. Okay, so type it in, and let's figure out where our branches go. For this question, our branches are in the top left and bottom right. And I'm not going to specifically tell you why the branches are where they're at. Right now, I just want you to use your calculator to be able to fill in those branches. Now, my domain. This is going to keep going to the left. Okay, remember domain is x's, so left. We're going left to -infinity. Okay, and then where is this going to stop? It's going to come up, but where's it going to stop? Left to right. Left to right, it's never going to go past what number? It's never going to go past this asymptote, and this asymptote is at -1. Then when I look at my second branch down here, I'm never going to cross this asymptote. So again, where's this one starting? This one's starting at -1, and then it's going to keep going to the right. And is it ever going to stop? No. So that second branch starts at -1 and keeps going to positive infinity. Range, remember ranges are y's. So we're down. This one's going down. It's never going to stop. And then up. Where does it stop upwise? Will this ever cross that asymptote? No. So we're going down to -infinity. And then we're going to stop right here at our asymptote, which is 1/3. Then how about the other one? We're joining that with the other one. So where does this one start? Remember, we're doing range, so up and down. This one starts at 1/3, and it's going to keep going up. So this one starts at 1/3, it keeps going up to positive infinity. Okay, so again, a little mix from what we've done in the past, but hopefully these are concepts that we can understand with what we did last chapter. So I hope you enjoyed our graphing today. This is going to be about the only graphing that we're going to talk about this chapter. So like I said, hopefully this was pretty easy for you. Here's your homework, practice B 1 through 16, practice C 8 and 10. Make sure on the questions that you're supposed to be graphing, you do all four things like we did in the notes: vertical asymptote, horizontal asymptote, domain, and range.